Alright, this is our 7th and final lesson on quadratic equations, and it's on interpreting the discriminant, which we have come to know as big D. So basically it's a whole lesson about big D. So let's have a look at this guy first. This is something we learned last time. Solve this equation using the quadratic formula. So we've already got everything on one side, 0 on the other side. So we got a equals 1, b equals 3, c equals 10. So big D is always b squared minus 4ac. In this case, big D is going to be 3 squared minus 4 times 1 times 10. So big D is negative 31. Okay, and remember last time we talked about first thing we do with big D when we put it in the other formula is square root it. So we already know that this guy's no solution. Okay, and that's why big D is called the discriminant. We can use it to discriminate between different numbers of solutions. We can tell the difference between different numbers of solutions with big D. For example, if big D is negative, we know it's no solution. Okay, so again, if D is less than 0, otherwise known as negative, then the quadratic equation has no real solutions. If D is 0, well, if D is 0, I'd end up with negative b plus or minus the square root of 0, oops, not 10, plus or minus the square root of 0 all over 2a, which would just be negative b over 2a. So I'd end up with just one solution if D was 0. Okay, and if D is greater than 0 or positive, then I'd end up with plus or minus some number. So that would give me two real solutions. So again, the discriminant allows us to discriminate between numbers of real solutions. Okay, so this one, notice they don't ask us to solve it. They just want to know how many real solutions there are. I can't get big D yet because I don't have everything on one side, so let's just add 9 to both sides. And I get x squared minus 6x plus 9 equals 0. So a is going to be 1, b is going to be negative 6, and c is 9. Alright, so big D is going to give me negative 6 squared, minus 4 times 1 times 9. D equals 0. If D is 0, I'm going to end up with plus minus 0, so it doesn't do anything, so I'm going to end up with only one real solution. Okay, important note down at the bottom here, the textbook may say something like, ask for the nature of the roots or how many real roots. This is just saying how many real solutions there are. Okay, and it would be way too easy if we were just using the discriminant to find the number of solutions. So let's have a look here. So this one wants to know values of k for which the equation has two real roots. I really don't like the real roots, so I'm going to change that to solutions. So we want to know for what value of k are we going to have two real solutions. Now we've got a equals 3, b equals negative 5, and c equals k because everything's on the same side and we have 0 on the other side. And if we have two real solutions, then big D is going to have to be positive, otherwise known as greater than 0. So we'll have negative 5 squared minus 4 times 3 times k has to be greater than 0. And now I'm going to subtract 25 from both sides. Oops. And now I divide both sides by negative 12. Notice that when I divide both sides by negative 12, our Pac-Man has to flip. So I get k is less than or equal to 25 over 12. So any value of k less than 25 over 12 is going to give us 2 real solutions. And now part B says, choose a value of k to write an equation that has 2 real solutions. So any value of k that's less than 25 over 12. So let's say, for example, we use k equals negative 247. That's less than 25 over 12 for sure. So that would be 3x squared minus 5x minus 247 equals 0. That will have two real solutions because k is less than 25 over 12. Okay, here's example 3 from the textbook. This guy's a bit weird. So we have the square of a number is subtracted from the number. Okay, so let's say x is the number. Then we've got the square of the number subtracted from the number. So there's the number, and there's the square of the number. Can the difference be positive? Okay, so I don't know. Let's just see whether or not it can be 1. The way we can see whether or not it can be 1 is I'm going to subtract 1 from both sides, and I end up with negative x squared plus x minus 1 equals 0. If this has at least one real solution, then the difference can be 1. So in this case, my d is going to be 1 squared minus 4, negative 1 times negative 1. D is going to be negative 3. Okay, so the difference can't be 1. Okay, well, let's figure out what it can be. So if I go x minus x squared equals k, and we throw that into the discriminant, it'll let us know what values of k will give us a real solution by setting d as greater than or equal to 0. So we subtract k from both sides. We get negative x squared plus x minus k equals 0. If this is going to have at least one solution, d has to be greater than or equal to 0. And d is going to be negative, is going to be 1 squared minus 4 times negative 1 times negative k. And that has to be greater than or equal to 0. So I get 1 minus 4k greater than or equal to 0. Minus 1 both sides, negative 4k is greater than or equal to negative 1. Divide by negative 4. Remember, our Pac-Man changes directions. So I get k is less than or equal to 1/4. So we do have some positive numbers there. Basically, between 0 and 1/4, those are possible differences, positive differences. So yes, the diff can be between whatever, 0 and 1/4.